All right, so let's look at um, some rewriting products or quotients of a radical. In this case, you have the same index but different radicand. So we can't simply just, well, I guess you can simply multiply them. You can add them together, but whatever. We're going to multiply these. And what you can do is, since they have the same index, you multiply the radicands together, you get 128. Now, you look for now you're simplifying a radical like you normally would, right? So 128 is not a perfect fifth power, but it has a factor 32 that is a perfect fifth power. So you split 128 into 32 and 4. The fifth root of 32 is 2. The fifth root of 4 is fifth root of 4. So the reduced radical form of fifth root of 16 times fifth root of 8 is 2 fifth root of 4. Here's a situation where the radicands are not the same. So you cannot simply, I'm sorry, where the index is not the same. And so you cannot simply just multiply them together. The radicands aren't the same as well, but that's not what's preventing you from multiplying these together. So what we're going to do is rewrite it using exponents, rational exponents. So the sixth root is an exponent of 1/6. Cube root is the exponent of 1/3. Notice how there's parentheses there because the exponents need to be on the numbers as well. So now you're going to need to write it with a common denominator on your exponent. So 1/3 would, as a common denominator of 6 would be 2/6. Then you can use the product property to split it out into basically it's powers of powers, right? So instead of 2x to the 2/6, you can say it's 2x squared raised to the power of 1/6. That exponent of 1/6 now can apply to everything. And then that means it is, well, 2x squared is going to turn 2x squared is going to be 4x squared. And then 4x squared times 8x is 32x cubed. And that's all going to be under the sixth root because 1/6 is the sixth root. So then you get sixth root of 32x cubed. Here's a situation where you got the cube root of 2n over 9m. So we're going to use the property that allows us to split it out. You got cube root of 2n over cube root of 9m. We need to rationalize. We cannot leave a radical in the denominator. So what is going to rationalize the denominator? We need to turn 9 into a cube number. 9 is 3 squared. So if I multiply it by 3, I get 3 cubed, which is 27. So I need to multiply the 9 by 3. The m is not a cube. If I multiply it by m squared, it will turn into m cubed. So I need to multiply numerator and denominator by cube root of 3m squared. So I end up with cube root of 6nm squared in the numerator, cube root of 27m cubed in the denominator. The point of getting 27m cubed in the denominator is because I can take the cube root of them and get 3m. All right. So the reduced radical form of the original expression is cube root of 6nm squared over 3m. We've got two more you try it questions. So pause it, try it, and then let me go over the answers with you. So the first part, in part A here, first I split it into numerator and denominator. I also simplified, or whatever you want to call it. I converted 16 into 2 to the 4th. And that allowed me to know that, all right, I need to multiply 2 to the 4th by 2 to the 1st, or just 2, to make it 2 to the 5th. And x cubed needs to be multiplied by x squared to make it x to the 5th. I need both exponents to be 5 or a multiple of 5, but in this case, they're both going to be 5 because they're under a 5th root and you need to rationalize. So I'm multiplying numerator and denominator by 5th root of 2x squared. When I do that, I get 5th root of 14x squared over 5th root of 2 to the 5th x to the 5th. So the 5th root of 2 to the 5th x to the 5th is 2x. The 5th root of 14x squared needs to stay the 5th root of 14x squared because there's no 5th powers there. So that ends up being your final answer. 5th root of 14x squared over 2x. All right, down here for part B, I have 27x squared. I'm just converting the radical form to exponential form here. So fourth root becomes exponent of 1/4. Square root becomes exponent of 1/2. I then convert the 1/2 into 2⁴. 2/4. That's all that happens from step 1 to step 2 here. In the third step, I rewrote 27 as 3 cubed, and that'll come in handy in a moment. And then I also did the power of powers property here. And instead of writing 3x to the power of 2/4, I did 3x squared raised to the power of 1/4. Now that they have the same exponent, I can combine the bases. So 3 to the third power, and this is going to end up being 3 squared. So 3 cubed times 3 squared is 3 to the 5th. And x squared times x squared is going to be x to the 4th. Then when I apply the power of 1/4 to both of them, 3 to the 5th can break into 3 to the 4th and 3. So that's why you have a 3 on the outside, which was the 3 to the 4th. When you take the 4th power of it, it just is 3. And then the other 3 has to stay. X to the 4th raised to the power of 1/4. Essentially, they cancel out, right? And you just get x. So 3x to the 4th root, 3x times 4th root of 3. All right, let's look at example 4.